Good afternoon, ladies and gentlemen. Our team would like to present to you SmartBox, innovative box by integrating micro:bit to transform the world. Hi, my name is Vincen Woenarta, and I'm here not alone because I'm with Rachel Rusli and also Kulkeev Almaz. So, let me introduce you to the micro:bit, a small-sized computer that is used to program all of the module. So basically, the micro:bit consists of LED lights. It has 25 dots, which is programmable, and it has two buttons and also a pin connector in the front side to connect all of the module. And the most interesting part is actually in the back side. So let me guide you to it. So in the backside, it has the most important part in the micro:bit, which is the CPU, Central Processing Unit. It executes the instruction by compromising the computer program. So basically, the CPU runs the module and giving instruction. The instruction given to the module is basically the instruction that is given by us, the programmer. So as you can see that the default micro:bit has only that four pins, and it is hard for us to connect the pin because uh, it's harder to connect it. So in order for us to connect all of the module, we need what we call as the edge connector breakout port, which is attached to the micro:bit and it acts as the extension. So it's basically have a 17 programmable pins, two serial data, and two serial clock, which is the I2C circuit. And it also has the 3-volt pin to power up the module and also the ground. So basically, what can be done by this small device, you may ask? So this smart box comes with a lot of features, but I would like to mention about the OLED screen. So it has the OLED screen to display the distance measurement and also the heartbeat result, and also the micro:bit, which acts as the brain of all of this module. And we also have the heart rate sensor, which will be attached to user's hand, and it can measure the beat per minute. And also we have the RGB LED light, which will change depending on your heart result, a 3.7-volt battery, which act as a external power supply. So you don't need you can so basically it makes this module portable. You can bring it anywhere. And it also has a ultrasonic sensor, which you can use to measure distance between you and an object. And lastly, the heart rate measurement module. So now I would like pass the time to Rachel Rusli.
Next, I'm going to discuss how the heart rate monitor works. So this flowchart displays the operation of the heart rate monitor. Firstly, an analog signal is received from the user's finger through the heart rate or pulse sensor on the smart box. The micro:bit will then take the 10 most recent data and will take the average, which is a moving average type. This means that the oldest data would be replaced by the newest data, which is taken in intervals of 20 milliseconds. If the moving average of the 10 signals taken is above the threshold value, which would be set in the system, the heartbeat would be taken into account, which also means that the heartbeat occurred. If this heartbeat is the first count, then the micro:bit would take the time taken for it to occur. But if it is not, then the system would repeat the loop again until it reaches the 11th beat, which the micro:bit would then take the time taken for it to occur. Hence, we can calculate the number of beats per minute using this formula displayed on the screen. So it basically multiplies the number of beats in 60 seconds and the number of beats per second. Moving on, we will now discuss the specifications of the OLED screen, which will display the measured heart rate. So an OLED is a flat light emitting technology made by placing a series of organic thin films between two conductors. It is basically an emissive layer placed between a cathode, which injects electrons, and an anode, which removes electrons. The OLED display works when an electrical current is applied, and it will emit a bright light. But how do we pattern an OLED display? So, since an OLED panel is made from a substrate, backplane, front plane, and an encapsulation layer, there are several ways to deposit and pattern these organic layers. Most OLED are made using vacuum evaporation, so we can use a shadow mask or an FMM, which is a fine metal mask, to pattern the display. Next, how does the SSD1306 OLED display work? So we first load the software code onto the micro:bit, And the OLED display would be connected to the microbit through an I2C connection as shown in the image below. The microbit would send information to the OLED display, and then the graphics would be shown on the OLED screen. This information is from the software code that is initially loaded to the microbit. So, how do we connect the microbit to the OLED display? So, this is the I2C connection of the microbit to the OLED display, and the green, red, yellow, and blue lines are wires. So, the ground pin in the microbit would be connected to the ground in OLED, the 3 volts to the power, pin 19 would be connected to the SCL pin, and pin 20 would be connected to the SDA pin.
Hello everyone, my name is Almaz and I'm continuing this presentation. So now I'm going to talk about the LED. First, the connection of LED to microbit. So the first, the LED have two connections. It is the first anode and cathode. So cathode you should connect to the ground pin of the microbit, and anode with the serial resistor connected, you should connect to the pin, any pin of the microbit. So how does an LED light up? So first you need to connect every color of this LED to the pins of the microbit, and then by adjusting the duty cycle of through the software, you may control the intensity of the light, and by combining these three fundamental colors, you may create whatever color you want. So next I'm going to talk about the ultrasonic meter ruler. First is hardware. So ultrasonic meter ruler consists of two main components. The first is ultrasonic sensor and second is microbit. So how does an ultrasonic sensor works? Ultrasonic ruler measures the distance by emitting a sound that travels to the object, and when the sound hits the object, it reflects and travels back to the ultrasonic sensor. So this is the transmitter called trigger and receiver called echo. Here you can see these pins, 4 pins, power, ground, trig, and echo. So next I'm going to talk about the connection. Trig is connected to pin 14, echo is pin 0. 3.3 volts on board is connected to microbit 3 volts, and ground also connected to 0 volts. So next I'm going to talk about the software. So the trig generates the sound and the starting time is measured. Next, echo receives the sound and also received time is measured. So the difference between these times, it is the time of the travel. And then by the given formula, microbit executes the calculation and measures the distance. And LED display shows the result. This is the formula. Distance is equal to speed multiplied by the time, difference of the time. And also don't forget to divide it by 2, because sound is travels to the object and the back. So how to make this code more to measure it more accurate? So first you need to define the function mean by yourself, because microbit don't have built-in function. So next you need to create a list and append the measurement values to this list, and then you need to remove all negative values or maybe too large values, and then you need to take the mean value. So this is how to make it more accurate. So next I'm going to show you a demonstration of this smart box. So this is the demonstration part of our presentation. So the first thing you see when you take this smart box is the this text on the LED: A is this, B is heart. So what does it mean? It means that you need to press the button A to start measuring the distance, and press the button B to switch to the heartbeat monitor system mode. So let's start with the heartbeat monitor system. So first we putting this on our finger and then pressing the button B. So it starts blinking. And also I would like to note that this LED lights up with the green if my heartbeat is less than 80. As you saw here, it was 72, so this is the green color. But when my heartbeat is bigger than the 80, it will light up with the red color. So to switch to the distance measuring mode, we are required to reset and then reset it and then press the button A. So as you can see here, it shows please press the A button. So it means to start measuring, you need to press button A again. Here is the distance, 25 centimeters. We are pressing the A button again, and it starts measuring. As you can see here, 25.2, it's pretty accurate. And let's make another measurement. The real distance is 15 centimeters. We are pressing the button A again, and it shows 15.3. So this is the end of our demonstration. The next is the question and answer section.